Welcome back. In this video, we are going to continue talking about ratios, proportions, and scales and their use in business. A proportion is related to but different from a ratio. Both are employed when there are total amounts made up of subsets or parts. But whereas a ratio gives the relation of the parts to each other, a proportion gives the relation of a part to the total amount. We have already calculated many proportions. We did it in the percentages section when we used Formula 4-2. Formula 4-2 was about calculating percentages from given numbers. To calculate a percentage, use the part over the total amount times 100. So the part divided by the whole amount portion of that formula is a proportion. And dividing the number of things in the part you are interested in by the total number is how proportions are calculated. This implies that proportions are between 0 and 1, which they are. Like percentages, they can go from having 0 out of the total amount, which would just be 0, or they can have all of the total amount at the other extreme, so that would be all divided by all, that would be 1, or they could be something in between. They could have, 40% of the total amount, that would be a proportion of 0.4. Anyway, continuing. Proportions and ratios are confused sometimes because the notation looks really kind of the same. For example, you could have a 1-to-2 ratio, or that same 1/2 could be a proportion. The 1-to-2 ratio means that for every 1 unit of one part, you need 2 units of the other. That's what a ratio is. It gives part to part. Whereas the 1/2 proportion means half of the total amounts. That's 50%. In business, that would usually be expressed as 0.5 instead of the 1/2. But either way, 1/2 could represent a proportion or a ratio, and they're very different things. So another source of confusion is that proportionality is involved when we use cross multiplication, like we've been using in our earlier examples in this section. Cross multiplication works because the ratios that we set equal to each other are proportional. So 3-to-1 and 18-to-6 ratios we figured out in example 9.1 are only different in that the second ratio is multiplied by a factor of 6. So 3 times 6 is 18, 1 times 6 is 6. So 3-to-1 and 18-to-6 are the same ratio, except for the second one is multiplied by a factor of 6, and that does not change the overall relation of the numbers to each other. Either way, the first part is 3 times as much as the second. That's what proportionality is, right? The proportion is maintained when the amounts are changed. That's why you have to figure out what is the new amount that I need to keep my proportion remaining the same when you're solving for x. When you set ratios equal to each other, you are using proportionality. But it does not mean that ratios are proportions. It is helpful to consider an example to make the difference between ratios and proportions concrete. So consider the advertising firm with the 3-to-1 high circulation to low circulation ad ratio that we dealt with at the outset of this section. What proportion of the ads they place for this client will be in the high circulation publication? So we have a 3-to-1 ratio, and we're being asked what proportion of the ads they place will be in the high circulation publication. And a proportion is an amount out of a total. So to calculate that, we have to consider a total number of ads. That has to be on the table because we have to plug that in as the bottom of our proportion. The easiest method when you have a ratio given to you is to simply add the parts of the ratio into a total. So 3 plus 1 equals 4 ads. So we have hypothetical 4 ads now. If the firm placed those 4 ads, 3 of them would be in the high circulation publication and 1 in the low in order to maintain the ratio. Therefore, the proportion of high circulation ads would be 3 ads divided by 4 total ads, which is 0.75 of the ads. So the proportion of low circulation ads would be 1 ad out of the 4 total ads, which would be a 0.25 proportion of the ads. Those proportions could very easily and would often be converted to percentages by multiplying by 100 because you heard how awkward it is to talk about proportions Proportions are very, very useful mathematically and in calculations, but then if you're trying to communicate, you just tend to convert them to percentages because then people will understand. The firm's 3-to-1 ratio of ads results in 75% of the ads for this client being placed in the high circulation publication and 25% of the ads being placed in the low circulation publication. And how I got that was simply 0.75 times 100 to get 75%, 0.25 times 100 to get 25% of the ads in the low circulation journal. So we've talked about that example. Let's work through example 9.5. Consider the pig iron ratio of 4 tons iron ore to 2 tons of coke to 1 ton of limestone to make 1 ton of pig iron. What is the proportion of each ingredient in the mix? So we have a 4 to 2 to 1 ratio, and we're only going to be dealing with the 4, the 2, and the 1 in the ratio, not with this 1 ton of pig iron, because we're being asked what is the proportion of each ingredient in the mix. That pig iron is what comes out of the process. So to convert our ratio into proportions, the first thing we're going to do is calculate that total amount. Why? Because we know that a proportion is going to equal a part, the number of things in a part or a subset of this group that we're looking at, over the total amount. Now we have tons, tons, and tons, so we can just add all this up. So the first thing to do is to add up the parts in the ratio to create a total amount. So it's 4 tons of iron ore to 2 tons of coke to 1 ton of limestone. And I'm not putting what each of these are because we're just adding up tons of stuff right now. And you get 7 tons. So you need to put 7 tons of stuff into this process in order to get 1 ton of pig iron out. And the second part is just to calculate the proportions. So we're going to use the formula proportion equals part over total amount. Total amount, of course, is 7 tons. So in our ratio, we are supposed to add 4 tons of iron, and our total number of tons that we're going to add is 7 tons. Let's do this to 3 decimals. 4 tons of ore over 7 tons total is 0.571. Now for the coke, we have 2 tons of coke in the ratio divided by 7 tons that we're going to add total. And we get 0.286, 0.2857. And since 7 is 5 or higher, we round the 5 in the thousandths place up to 6. And lime. We use 1 ton of lime in that 7 tons total, and we get the proportion 0.143. Now notice that we have calculated every part of these tons. We have exhaustively calculated out the ingredients. There's only 3 ingredients here, 7 tons total, and if you add up all the ingredients we added, that adds up to 7 tons, so that's all there is. So the deal is these proportions, just like how percentages should add up to 100% if they cover all the possibilities, these proportions should add up to 1 if they cover all the possibilities. So if you take 0.571 plus 0.286 plus 0.143, unless there is some sort of rounding error, which in this case, thankfully there is not, you get 1. Proportions split up 1 in proportion with the thing that you're measuring. So notice that the proportions we have worked with here all apply to quantities that have the same units. Doesn't mean they're the same thing, but they have the same units. For the ads, the ratio was a number of ads to number of ads. So we could calculate proportions of ads, right? Proportion placed in one place, proportion placed in another place, but it's still proportions of ads. For the pig iron, the ratio was tons to tons to tons. Even though it's 3 different things, because all of the parts are in the same units, we can freely combine them to calculate the proportions in the case of these ratios. The thing about ratios, though, that's different from proportions is that ratios in general can have parts with very different units. For example, you could have a ratio of apples to people if you were planning, say, a party. In that case, it would not make sense to combine the number of apples and the number of people to calculate a proportion of apples and people, right? Like what percent of the apples and people are apples? That doesn't make any sense. Proportions are always parts of total amounts, and those total amounts must all be in the same units. So when you're talking about proportions, you're talking about the same unit on the top as on the bottom, because what's on the top is a subset of what's on the bottom. In this unit, we presented proportions along with ratios in order to distinguish them, but they are separate things and they don't always need to work together. Sometimes you use ratios and you don't care about proportions at all. Sometimes you use proportions and you don't care about ratios at all. Here is a problem that deals only with proportions to demonstrate. Example 9.6 says, a retailer has 12,341 items in inventory. 8,324 items were classified as formal wear, 3,016 of them were classified as accessories, and 1,001 items were classified as footwear. What proportion of the retailer's inventory items are formal wear? What proportion are footwear? Report the proportions to 3 decimals. So reading this, what we're given is that this retailer has 12,341 items in inventory, and that is a total amount if I've ever seen one. Now, it did not have to be given in this case because we're given a problem with 3 different things in inventory: formal wear, accessories, and footwear. And we could be asked about proportions just being given those 3 numbers, because if you add up 8,324 pieces of formal wear plus 3,016 accessories plus 1,001 pairs of footwear, you get 12,341 items in inventory. What proportion of the retailer's inventory items are formal wear? 8,324 items were classified as formal wear. That's the part we're interested in. And the total number of items is 12,341. And what you get is 0.674. Mentally converting this to a percentage by multiplying by 100, 67.4% of their inventory is formal wear. So the majority of their items, more than 2/3 of their items, are formal wear. Then we're asked about footwear. There are 1,001 items of footwear in the inventory. Divide by the 12,341 items total. And to the 1,000th place, you get 0.081. So 8.1% of this store's inventory is footwear. So this isn't stated in the problem, but I would like to know if we can come up with a way, without calculating it directly, what is the proportion of accessories? What we can use is the fact that we covered in example 9.5, that if your proportions are exhaustive, that is, they give you a classification for every single thing in the group that you're looking at, then they add up to 1. So 1 minus the proportion of formal wear minus the proportion of footwear is going to give you the remainder, which is going to be the proportion of accessories. This works because we had every single thing in the 12,341 items classified into one of the groups that we have here. So 1 minus 0.674, that's our proportion of formal wear, minus our proportion of footwear, 0.081, and we get 0.245, so 24.5%, or a proportion of 0.245 of the retailer's inventory consists of accessories.